طيب, another types of measurement devices that measure the density is the pycnometer. Pycnometer is a device that measures the density by fixing the volume. It is a glass flask with a close-fitting ground glass stopper with a caliper hole through it. This fine hole releases a spare liquid after closing a top-filled pycometer, and allows for obtaining a given volume of measured and working liquid with high accuracy. Normally, they compare it with the water.
These clever little gadgets. It's called a pycnometer, and here's how it works. A pycnometer consists of two pieces, a small flask and a glass stopper with a built-in capillary tube. When you fill the flask to the bottom of the neck and then insert the stopper, the liquid is forced up to the tip of the capillary. Dab away any excess, and the liquid is guaranteed to occupy a volume that is very precisely prescribed. Once you've determined what that volume is, it's trivial to measure the density of any liquid simply by measuring its weight.
Now, usually they're using this pycnometer to compare material density with the distillated water, as you saw in the videos. Okay, now if we say that the same volume, that means the volume of the liquid equal the volume of water. So I can say volume of liquid equal the volume of water, or I can substitute for the volume based on the density formula, which is mass of the liquid over the density of the liquid, which is equal mass of water over the density of water. I know the density of water already is known to us, which is the distillated water density at defined temperature, either 25 to 20, 0%, 0 degrees Celsius, whatever, depending on the degree or the ambient temperature around the pycnometer during these times, which is multiplied by the mass of the liquid over the mass of water. Just I need to find the mass of the liquid using the normal balance and divided by the mass of the water also using the same balance. Just multiply them and it will give me the density of this liquid. So pycnometer, it's apply the rules that changing the mass with fixing the volume. Here is example. A density of distillated water is 997.05 kilogram per meter cube at 20 degrees Celsius. Use in pycnometer to find the type of material, which give a weight 12.64 Newton. What is this material? So he told me distillated water is used in pycnometer, and he told me that the weight for this material is 12.64 Newton. And also to give me material mass for the water. I forgot to mention it there. It's mentioned here, shabab. It's mentioned here. See here, shabab, the mass of water itself, which is in reality they give me a weight 11.775 Newton as a weight. Okay, now this is the formula. Density of liquid equal density of water multiply the mass of liquid over the mass of water. We know to find the mass of liquid, just divide the given weight by the acceleration of gravity. The same thing for the water. Just take it and divide its weight with the acceleration of gravity. Divide both of them and multiply them in the density of water. It gives me the final results. So my material is 1449 kilogram per meter cube. If you search in the web, and you will find the tables there for some common fluids, and if you see this value, you will discover it is what? Acetic acid. So my material is what? Acetic acid. Okay, this is a method for using picnometer for measuring the density. The accuracy for this type is really, it's a little bit very high. It's more higher and more accurate, better than the previous displacement one. Okay, let's go to the next technology, vibration sensor. Aha, it is an alternate method of measuring the density of any fluid. The fluid will pass through a tube which has a flexible mount so that it can vibrate when driven through outside the source. The amplitude of vibration decreases as the specific weight or the density of fluid increases. It's opposite relations. So that by measuring the vibration amplitude, the specific weight density can be calculated. It is built on idea of harmonic motion of the spring. What's the harmonic motion of the spring? Look at here يا شباب. By using the Newton's second law and also utilizing the Hooke's law. This one is Hooke's law. This one is Hooke's law يا شباب. Hooke's law, it's saying that the force change proportional to the displacement of the spring. It's saying that the force needed to extend or compress a spring by some distance is proportional to that distance. So it's direct relation between the distance of the object that is exposed to the extension or compressing, utilizing the spring, and the spring, it has certain factor depend on the design and the manufacturing of this spring, which will give rate of proportionalities between the displacement and this spring. If you see here Newton's second law, it's saying that m multiply g, which is the weight of the object. See, I suspend that object vertically, so the gravity will pull it down, and the spring will resist this force. It will pull it up. So it will pull it up. The ball will be pulled by the gravity, and the spring will resist this force. That's why I mentioned this is what's minus k, opposite to the gravity. The gravity mg comes down, while the force that applied by this spring, which is expressed by the Hooke's law, this is the Hooke's law, it's saying that it is proportional to the distance, the force that be applied by the spring, as in our this example, it is opposite direction of the ground gravity. So that's why I put here minus sign. It is negative because it is against the gravity. Positive if it's going through the same direction of gravity. So by Hooke's law, minus kx is going up opposite the gravity, so I give it a minus sign, will resist this weight of the object, mass multiply g. So the difference between them, there is certain apparent force comes now, which is can expressed as mass multiplied acceleration, and this acceleration I can say it is what, Shabab? It is the rate of change for the distance, or for the speed over the time. The speed change by the time. See here, Shabab. If you see here, Shabab, distance I can express it as function of time. I give this a symbol to indicate for the distance xt, just the distance, function of time, what show me the distance through the time. Now if I differentiate it, and when I say differentiate, mean the rate of change of the distance per the time, or dx over dt, again the change in the distance per the change in the time is what? Is the speed. I can give a symbol for it. It is S function. This S function, it is really a derivations for the X function. Okay, now let's go to the acceleration. Acceleration, it is the change of the speed, which is S function here, through the change that of the time. Again, the change in the speed bear the change of the time, so it is the rate change by the time, ds over dt. But if I substitute for s with this dx over t, it gives me what? D square x over dt square. So it is the second order derivation. It is second order derivation of what? Of distance. So it's here, substitute this acceleration by d square x over dt square and multiply them by m. It gives me the apparent force resultant from where? From the gravity weight and the force exerted by the spring, and give me this apparent one. If you want to solve this equation, is not in our scope in this course, it is mathematical strategy. Solving this second order differential equation, the answer for it is give me this. This is the function of the time, xt, which is expressed as amplitude of sine waves function with resonance frequency. See here يا شباب, omega t minus phi, this one you call it phase shift, plus constant. What is this, the constant b? If we solve this equation, substitute this x here يا شباب and here, then differentiate and make everything. When you make, you will find this resultant equation, mg, which is the same, minus k, and instead of x I put this function, which is a function of time, function of distance, and m just coming down, and I differentiate this time 2 times, differentiate this function 2 times. First differentiation, then I differentiate the first differentiation also again, which is give me this resultant function. Reordering things, then you'll discover that b, it is give me this one, mg over k. Okay, and in order to go to find the resonance frequency, which is w here, omega, sorry, the omega, my omega here, you will discover that our omega square, it is give me k over m. Just give it a square root, you will find the omega itself without square roots. So this is my function. Instead of omega, I just divide this omega by 2 pi. It gives me what? My frequency. So substitute this 2 pi over omega and substitute my omega with this function, resonance frequency. Substitute it here, or we can reorder them again. It gives me that mass equal the 4 pi square frequency square over the constant of a spring. So F is the natural resonance of the frequency, K is the spring constant. In our case, it is the stiffness constant of the tube. Mass is m, denoted by m. Okay. Okay, vibration, I can say the mass, total mass of the vibrated tube, including the fluid inside it, it is the mass of the fluid plus the mass of the tube. Or if I can say, using the formula of the density, I can say that the mass of the fluid over the volume of what? Of the tube, because it's fluid. I have to take the shape of its container. So the volume of kits container is the volume for my fluid. And we know that mass of the fluid is contained of two things. M, total M, minus the mass of the tube. And divide them by the volume of the tube. Just substitute for this M from our previous formula. Just substitute it here. And you will see this is my volume of the tube and this is the mass here. Just substitute it by the K over 4 by square over F. I forgot يا شباب, there is a mistake here. It should be M equal K, this one is a mistake, over 4 by square and F square. Sorry for this mistake شباب. Now substitute it here, then just some manipulation, it gives you this resultant equation. So I can find the density of the fluid by applying this formula. Okay, if we have U-tube flexible sensor which has as example 0.00141 meter cube volume and 8,372 Newton per meter stiffness constant and 0.382 kg mass, what will be the density of the material that passed through it, and it generates a resonance equal around 20 hertz. Okay, see here يا شباب, this is the macro motion device which measure the density. The fluid will go through this tube and the tube start vibrating as you see here يا شباب. See the sensor, how can they act with the vibration of this tube, U-tube, we call it U-tube, U shape, in the U shape. Now it's filled by the material and it will vibrate. Inlet back off and outlet back off. The inlet when mean دخول, لحظة دخول المادة جوة الأنابيب. outlet لحظة خروج المادة من الأنابيب. طيب, in phase, that's mean at the same angle. But if there is a material start in there and the density change, see the vibration, how can it affect on the sensor catching frequency. And you will see there is a change in the phase. Shift, phase, shift, phase, shift. Now by finding this phase shift, I can find delta t. And I know that the acceleration is opposite, it's proportional to the delta t. So I can find here mass flow rate. Then frequency, I can catch the density by using the frequency. I know the delta t now. Just find the frequency by converting this delta t 1 over the time and give me the resonance frequency. Maybe you can see here the difference in the masses. Heavy mass, it has heavy frequency. Light mass, it has frequent or very fast frequency. So if the material is heavy, its frequency becomes heavier. If the material is very low, its frequency becomes upper. So this is the relation. This is the relation of its density is opposite relation to the square of the frequency. So we return back to our formula in our question. Now I know that the density of the fluid will be opposite relation to what? To my frequency, as shown by the previous video. Now the K here is given to me. Substitute my frequency, which is given here as 30. Also another mistake, it should be 20 شباب, not 30. It's 20. 20 square as frequency. And see here this is the hertz ها يا شباب, this is hertz ها يا شباب. 1 over s square, it is what? Hertz square ها, the unit of frequency hertz, it is 1 over s. Just substitute for the volume which is giving to me here. This is the volume of the V tube, it is the same here. Substitute both of them in the both sides, and it's already give me the mass of the tube, the mass of the tube. So just simple substitution and give me what? Density of the fluid, 1048, which is our acetic acid. So this is the vibration sensor methodology for measuring the density. Okay. Another method for measuring the density, which is the differential populars. It's based on the idea of changing the pressure. It is the idea of changing the pressure over the difference in the height. If we fix the height and make it fixed, we can just measure the change in the pressure here, and based on that I can measure the density here. So as example, let's take this example. What is the density of a liquid in popular system? If a pressure of 500 Pascal and 2300 kilopascal are measured at the depth of 15 centimeter and 6.5 meter respectively. See here يا شباب, this one is example. There is here height and here the another height. In our example, it's saying that this one is 15 centimeter, while this one is 6.5 meters, and it gives me the difference between them and the pressure. See here, this is the high and this one the low, low and high. So in our example here, I can utilize the same formula. Density is equal to the differential pressure over the G over L, and we know that L, to find it, is 6.5 meter minus the 15 centimeter. Of course I divided by 100 in order to unify the units, so it gives me 6.35 meter. This is the height. Then substitute the height here for the L. It gives me differential pressure, which is 23,000 minus 5, 23 kilopascal يا شباب, 23 kilopascal. It is kilo, that's why I put 3 zeros here, and 500 pascal here, which is the low density side. Just subtract both of them and divide them by the acceleration of gravity and the length that we already found it here. It gives me the result, which is 361.193 kg per meter cube. So this is the simplest method. It is simple method and it is helpful. Most of the time is used for the reservoirs and tanks, because here you just put a simple tube, not cost. So if you have some corrosive material or some harsh material, just put a tube on it, even though if the tube is raided or it's exposed to the corrosion, you can change it simple and it's not that much cost, in order to save your devices or your sensors. Now other techniques also used for measuring the density, like radioactive sensor or vibration forks. This is the density meter using the nuclear atoms or nuclear material. Here is the emitter that emits the radiations, and here are detectors that detects the radiation that went through the pipe, and here a display panel that show me the readings of these radiated waves. Now the material go through the pipes, the active substance will radiate and start reading. If the material increases in the density, see the waves will disappear through the material and will not reach in the detectors. So the amount of wave reach there, it becomes very low. That means more density. And this is the imbalance. Another method for measuring the density, it is the vibrated forks. Also the same principle like vibrating tube. See, if you have a mass, heavy mass, it has low frequency. Light mass, it has higher frequency because it's lighter, easier. So the density here is opposite relation to the frequency. The same principle, shabab, almost the same. Vibrating, but instead of putting a tube, I just only put forks. And here is the piezoelectric crystals with the temperature sensor in order to give you also the measurement of the density using the vibration forks. This is the device, and it gives you here some displacement is manufactured by one of the companies, Emerson, I think. Let's call it motion. See here, the material with with the very heavy density, it will go through the forks. The forks start vibrating, and these vibrations will go through the sensors, as you see here, and this vibrating will be generated in order to give you the signal to the my transmitter, as seen in the picture here. If you take it out, maybe you notice their vibration will be affected a little bit more, not like previous. So there is some difference in the vibration here. Will change the frequency of the vibration, but of course still you are measuring the density. Maybe if we see here, this is depend on the real-time density measurement accuracy up to 1 kg per meter cube or up to 0.001 gram per centimeter cube. So this is the type of my fork measurement. Okay, shabab, by end of this video we already covered the subject of the density. We talk about the density in details, more details, and we take some formula and we solve some example for it. Don't forget, shabab, solve the question number 1 of the quiz number 1, and I will give you a location where you will submit this quiz. Thank you, shabab, for listening and waiting me for the third lecture. Assalamu alaikum.